Hi, so now we're gonna solve number 3. We're solving the linear system. So we have our linear system using the eigenvalues, eigenvectors. Also, this is like linear algebra. I remember seeing this material in linear algebra. Also, if you took it, you're gonna be familiarized with these terms. First, I write the system in matrix of form of x prime equal ax, where the coefficient of the matrix is this matrix a equals 3, 1, 4, negative 2. Two rows, 2 columns for this matrix. Next, I find the eigenvalues. We're gonna use this one. Also, it's always good to know the symbols. So I left the symbols meaning right here, just in case you have questions or something. Especially these Greek symbols, like this is lambda. It's always good to remember that. So I subtract lambda from the diagonal entries. Once I do that, I compute the determinant. I do the expanding, and then let's simplify. So once I simplify, I'm gonna get lambda to the power of 2, or lambda squared, minus lambda minus 10 equals 0. Okay, so now let's solve the quadratic equation. So once we got we can solve it in the calculator. We can use the general formula. I always prefer to do the general formula. It's always accurate and quick. So once we got the two eigenvalues, which is right here, plus and the positive and the negative value. So now we find the eigenvectors for the first eigenvalue. We're gonna solve it using the first row. So this is gonna be the first row, solving for y. So let's choose x equals 1. The eigenvector becomes this is gonna be our vector. So it's gonna be only 2 rows. For the second eigenvalue, let's use the first row, choosing x equals 1. The second eigenvector will be this one right here. So now let's write the general solution, and the solution to the system is gonna be this one. So now we're gonna see the graphing. You can see right here the graphing. So this graph represents the phase portrait of the linear system, and then we're gonna have right here of 2 x prime and y prime. We can see the graphing, and also we're gonna attach the link.